Welcome to the high energy physics lab of the glue and paper guy. In no uniform today, I'm here to show you how you can mix fire and paper and make something beautiful. Right now what's going on in the background is the final step of several. The first being to make your part with Inkscape. The second being to check your pattern with something called laser Gerbil. And the third being to cut it with something called light burn. Inkscape is a vector drawing program. I'm going to do a tutorial. The other two are pretty much clickety-click with specifics to each laser. This is my process to make mathematically precise flat things into three-dimensional objects. This is a huge sheet of itty-bitty dots. I'm going to make these into bolts on a specific project. A disclaimer: lasers will hurt you. Unless you know what you're doing, don't screw with them. Keep them ventilated, don't look directly at the beam, wear something to protect your eyes, always. Welcome to Inkscape. Inkscape version 1.2 is N-1. 1.3 is out. It has a bunch of improvements. I stay with 1.2 because I have a Linux distro running that has 1.2 on it. So I need to stay version consistent. This thing has more buttons on it than the Millennium Falcon. Doesn't matter. We're only going to use a small set of those to do this drawing. All laser cutters cut with SVG files. Inkscape produces native SVG files. They cut very nicely. So we're going to do a drawing and then move on to the next steps in the flow. We're going to start with a bunch of circles. This is the basis of a trefoil. It's a simplistic design to demonstrate how you do this. You can go crazy and draw an entire ATST, much like what I did. How do you make a circle? You pick a tool. All this is about picking the tools. Sizes matter not. I made a circle. That one happens to be round. There's a better way to do that. You can always undo with Control Z. Shift Control, click, drag. I have a mathematically guaranteed round circle. I switch tools on you there. Now I have the cursor tool. It's like the hand. You just pick it up and move stuff around this way with the cursor tool. That's everywhere in every vector drawing program that was ever made. We're going to make it a little bigger. I'm going to make sure I stay on Shift Control to make it bigger. There's no dimensionality to this whatsoever. Size doesn't matter here. So you have a shape. This is a vector shape with a radius, a position, a direction, line thickness, and fill. The control panel there on the right controls what I want to do with the line. There's an alignment thing there. This is for fill. I can turn it off, turn it back on. That'll become important later. I can change the fill color. Anything on the spectrum down here at the bottom of the screen. Just pick one, something random. Nah, salmon pink. That's a little better. Parenthetically, there's an opacity. Down here on the lower right, you see that I have the opacity set at about half. But just do that. It makes some things easier for me. So now I have the basis of my circle. We talked about the fill. A stroke is the line around it. Go to fill, turn the fill off. Now I have a stroke. And I can make the stroke whatever I want it to be. That's not a good way to make a circle for a vector. point is, you control the line and you control the fill of every shape. I'm going to set that value back to 0.2 millimeter because I want it to stay that way. I'm going to put the fill back in because it makes things a little easier. Now I'm going to make a series of circles. I'll try to call them off. Every time I hit the Control D key, I get another circle. It comes up right on top of the next one, which you'll see. Control D. See how they got a little darker? Now there are two shapes. Control Z to go back always. I want this one a different color. It's going to be green. Control Shift. More or less arbitrarily, that big. I want another one. So you see, it got darker again. I added another circle. There. Different color. Control Shift. I said I'd call them off. Let's pause just for a second and review, and then you'll see where we're going here. That's as big as the trefoil will be. This will become the border of the trefoil. This is the inside of the border of the trefoil. Duplicate. Got another shape. Control Shift. That's the outermost diameter of the blades. Control D. Oh, I didn't hit Control Shift. We'll go back. Shift Control. Symmetrical sizing. That's the innermost diameter of the blades. Now I need the last detail. Duplicate it again. Control Shift. That's the circle in the middle. So I have the full size, the border, the blades, the three foils of the tray, where they stop, and the centerpiece. I want to know where the centers are because I'm going to put what amounts to scaffolding. If anybody who's ever done drawing, drafting, you do construction lines and then you draw this beautifully finished art piece. I always use construction lines because I started off as a draftsman. So, some drafting lines. Different set of tools. A Bezier curve is, look it up. It's a malleable curve. You can make soft shapes with them and do other things. So I select the Bezier curve, and I want to make a line. I want to make two lines. Lean on Control. When I have the Bezier curve tool, you notice its cursor changed. It looks like a pen tip. So I lean on the Control key, click, and drag down. I let go, click twice. I now have a perfectly vertical line. Start again. Control key, click, drag, release, double click, perfectly horizontal line. Black vertical and horizontal lines. I don't want black vertical and horizontal lines. I want red ones. I change the tool to the select tool. Now here's the trick. I'm leaning on the Shift key. That means I can select multiple items. See how the border changed here? And these changed color? I have two items now in my fist, ready to do as I please with them. And I can pick them up and I can move them around as a piece. What I'm going to do with them now is I'm going to change their stroke color. It's very simple. Good old Shift key, pick a new color. I always make my construction lines red. Tradition. So when I select away from this, I have a vertical and horizontal line. They're relatively thick for these purposes. So I can control the width, as I showed, of the line.
Stroke style. I pretty much run everything at 0.2 millimeter nowadays. You may have noticed that it changed, but it's the, what, 65 thousandths in width? Not that big. All right. I have some fundamental construction here. Now things get interesting. Math is Boolean in Inkscape and in every other vector art program. No quiz later, it's not hard, but machine is going to subtract one shape from another and eliminate the thing that was subtracted. I want to make a ring out of one of the circles. That's going to be the border for the trefoil. This circle right here is going to become a ring. So I'm going to select the bottom one and then the top one, and I'm going to hit the subtract button. For my convenience, I'm going to move the thing that's over top of it out of the way so that I know for a fact I'm selecting the right things. You select everything. I'm going to select the bottom one, hit the shift key, select the top one. Now I have borders here showing me which shapes I have selected. Therefore, I can subtract them. Somewhere snuggled up here in the path menu are these Boolean operations. Union, difference, intersection. And you can imagine what they do. They literally do math on a shape. They subtract part from another, they add pieces, they change the borders, they do stuff to shapes. In this case, I'm going to subtract the bluish from the greenish. Bang. Now I have a ring. That's our border. I want to get everything lined up again. Control A, alignment, everything's lined up again. Color of that shape is getting annoying. I'm going to change it to something else. Now I can see it again. So I have the background, I have the border. This blue is going to be the blades, and we'll make the blades later. Right now, we're going to make it into a ring, because the blades don't touch. Same trick. Select the bottom one, select the top one, then subtract. I'm also just going to make sure that the math is worked out right. I'm going to make sure that the circle that I have selected now is on the top of the heap, because then I know I'm selecting the back and then the front. Select the top one, shift, select the next one, path, difference, bang. I have a bunch of rings. It's now time to make the blades. I'm going to use a different tool. I'm going to use the star tool. It can make stars, it can make shapes of any number of sides. Up here on the top, I can tell it to make 6. So if I come over here, any random place on the canvas, and I start making a 6-sided figure, I can then move it over top of the others and use it for a guide. I can pick any one of these shapes because they're all aligned. So I just want one to align to the others. So I pick the middle circle, shift, pick the hexagon, center, middle. Needs to be a little bigger. Control shift. And you see how the shape is cockeyed there? I want it to line up to that dashed border. So if I do that, I got it lined up to the dash border, deselect it. How did I turn it? Selected it, clicked again, and now I can freely turn the shape. in any direction. I'm going to empty it. Fill, X. Now I'm back to my kaleidoscope. I'm just going to make sure that everything's lined up one more time. There we go. I'm going to go back to the same tool and I'm going to use it in a very similar way to what you saw earlier. We're going to go back to the Boolean. We're going to subtract some stuff. So there's my star tool. 5, 4, 3. I now have triangles, ladies and gentlemen. I'm going to make as vertical a triangle as I can. I'll probably have to circle, do a little adjusting. In fact, I know I do because it's Kitty Wumpus. Selector tool, click it again, and you'll notice that Inkscape remembers the last shape parameters that you used. So since it remembers the last shape parameters, it just gives me another empty red triangle, which is incredibly useful at this point. So select away from it. Got to click on the line if you're going to select an empty shape. Select it again. Is it big enough? Probably. I'll make it a little bigger. Control Shift, always. Test it again. I like it. This is all eyeball. There may be ways in the program to constrain this closer. We don't need it any more mathematically perfect than we're going to do it here. So it's eyeballed. I need 2 more of these. I'm going to fill it. Blue's fine. I'm going to differentiate it. I don't know that I'm using any yellows right now. Now I have a yellow one. Duped it twice. See how it got darker? And interestingly, let me try something. Yeah, see? I don't have to rotate it. I don't have to change it. I don't have to do anything. Select away from that. Oops. See how that's beginning to look like the final shape? Because it will be in a minute. I'm going to get in there and I'm going to get a little more precise with it. And then we're going to start doing the math. And you'll find that we have created our trefoil. Getting closer, going further, always very important in vector drawing programs, and wickedly easy to do in Inkscape. My finger's on the control key. See that? Now I get an eyeball of how straight I really was. And we also see that these are cockeyed. We're going to fix this. See, in fact, let me take you in here a little closer. Scroll bars at the side that help you move back and forth, up and down. So now, if I zoom in this a little closer, see how those are out of kilter? Easy to fix. Select that line. There's handles telling me that it's selected. Even though I'm looking at only this much of the picture, I know that I've selected the line. Shift key, got a triangle. I got all those things selected now. Back to the alignment. And this is where you have to pay attention. These buttons look the same, do different things. I cost myself 3 days worth of grief from that. If you hover over them for a minute, it will tell you what it intends to do for you. I'm going to align the bottom edge of the second thing I selected to the first thing I selected by picking the button that says Align Bottom Edges. Bang. Now I can really see how crooked my triangles are because I can see where they're attached to the line and not attached to the line. Control, other direction. I gotta go all the way back out to do this. So I unselected everything, and you see how you can. And believe it or not, that's sometimes useful because I'll be working on something in this area, and I'll drag a shape off the page. There's a button, takes you right back. Now I got my triangle. I can get down and dirty. That, believe it or not, is the turn handle. Okay, now it's square. And the other one. Handles changing. That's what those little marks are, by the way. They're handles. Another universal. That is really close. Now, I'm satisfied that I have those squared. I'm going to check the alignment of the third one. It's as close as the others. At this scale, I can see the flaws. And I don't know if you caught it or not, but the line width changed. That's me lining it up. And you see how this fat here? Oops. I don't know what I did just there. I mean, it's really, really close. And maybe it might be the best we can do. Close enough. I want everybody lined up. Just look at the page again. So I'm going to select this construction line here. Shift. And make sure I'm only selecting what I want. Shift. And the reason this is big like this is because that line is the biggest. You will see the handles around the largest part of the shape you chose. I want this to hit that line. Back over here, align right edges. You got to check your rights and your lefts. Now, I'm going to do the same thing the other way. Align left edges. And you may have noticed a little twitch as it goes into place. Select the center, select the bottom one, align center, let go, find your line, oops. See, when you got a bunch of stuff laying on top of each other, it gets tough. There's other ways to fix this particular annoying problem. What I'm trying to do is grab the line. There, now I have the line. You fix the annoying problem by changing the order of things. If I move the lines up top, when I touch there, I'll get them instead of this triangle. The lines are, everything is like this. So there's the shape, then there's the lines, and there's etc. like that. And that's just part of the deal. Shift, grab the other triangle, align top. This button is align top. It looks exactly like the icon over here, which says align top edges of objects to bottom edge of anchor. I want to do that because it looks weird. So I want to align the top edges. That's an absolute. Shift. See, I went backwards too. If I hit the shift key, I can deselect something and keep the other selection that I had. Back on the shift key. Back, make sure they're, this is, the final swipe. Again, align bottom edges to the top edge of the anchor. What I'm doing is I'm reading the pop-up that doesn't, oh, look at there, it does show. Fantastic. Align bottom edges. All that grief. And we're going to totally get rid of our pretty yellow triangles. So now here comes the math. Everything's deselected. The lower object first. That's the circle I want to change. And then one at a time is best for this. There are other products you can just select everything and just do the math. This one doesn't like to do that. So the lower object first, then the higher object. It's one of the triangles. Path, difference. Starting to look like something, isn't it? The lower object first. I don't want to rotate it. I find it's a good idea to deselect in between operations. Lower object first. Upper object. Handles change. Path. Difference. And one more time. Now, here's an interesting thing about the math. Watch this. Think about your expectation, and then watch what happens. See that? You would expect that those would then be three separate pieces. They're not. It's still one mathematical vector with missing bits, which is convenient as I'll spit in this project. That really looks like something now, doesn't it? Okay, it is. It's exactly what we want. From here, it's all downhill. You do the cleanup, set it up for the cut, and then you move on to the next product. Okay, deselect everything. Select, shift, select, select. You see the colors change on the lines. So I have the last of my construction lines gone. Do a couple things here. First, here's the power of vector. I'm going to do something called grouping. All of these are going to become one thing. Right click, group. Did you notice how you lost these other edge lines? Now, I got the whole thing. Well, at this point, I'm ready to break it up and prepare it for cut. So, think in your mind. I have a base, and I have detail layer, and I'm counting. I have a base, and I have detail layer, 4, 5, 6 bits of detail. And they'll have to ultimately be separated up to get cut. So for now, I'll have to do Control Shift again, always. I can make it whatever size I want. Once I have my design, I can do that anytime I need. I can have tray foils that are tiny that I can put on the side of a model, or tray foils that are huge that I can use to cover an entire door. Same machine. Most laser cutters, entry-level laser cutters, are constrained to about 300 millimeter by 300 millimeters. Some will go 4. I think mine goes out to, in its original configuration, mine went out to 400 millimeter each way. So, partially demonstration, partially convenience. I'll do something else too, watch. I've selected the whole group. I don't have my hands on the keyboard. Nothing up my sleeve. See how the math is calculated anyway? Now I can make it go away. If I don't have Shift Control, the program assumes that I'm going to make a change only with the handle that I'm working with. If I do Shift Control, the program performs the operation symmetrically. I want it about that big for demonstration purposes. I can have as many of them as I want. Watch. Control D, Control D, Control D, Control D. Notice how the color is becoming more intense? It's because if the shape has a 50% transparency, instead of 50, 50, 150. I don't know how many times I hit the key. There's another one. There's another one. There's another one. There's another one. I don't need all of those. So I select 3, hit the delete key, they're gone. See there? So now you see the power. I only ever drew one leg of an ATSD because I could. You draw one, you duplicate it, you reverse it, you have the other side. Sometimes you don't even need to reverse it. Sorry, keep the main thing the main thing. What am I going to do here? I'm going to do 2 things. I am going to duplicate it once, and I'm going to move it over here, because the easiest way to do this is to have the 2 shapes. Select this one, ungroup it. Now demonstrate the difference. What? Okay, so on this side we got group, on this side we got ungroup. Take a hold of this one set of handles, the whole thing. Put it back just for convenience. On this one, it's separate pieces again, which is fine, because I want to have the separate pieces to construct it. Then why'd you do that? I'll show you. These are now all separate pieces. They're going to get a specific line width to constrain the width of the cut for the laser. They're going to get a colored background to make them easier to manipulate. And then this one is going to be told to be 2 things. A big circle to cut out and some details to guide where I put these. So I'm back to this shape. Ungroup. See how I got all these extras here now? That's ungrouped. That's a bunch of separate pieces. Just by way of proof. Now, I'm going to select this one. But still, a whole piece of math, right? The math says that there are 3 chunks to this, and it treats it as a single thing. And we'll select the center, and we'll select the ring. I'm going to go over here, back to my fill tab. I'm going to turn off the fill. But wait, Tim, you can't see anything. Yes, you can. Hang on. Those lines are red. And I know that because down here in the very lower left corner, it tells me the stroke is red, the fill is none. I want that to stay there. Deselect everything. By clicking that empty area, I can select the biggest circle, and I can change its fill. Fill changes a direct function. Stroke changes a shift function. I'm not doing anything. That's a 75%, 7.5% gray. I'll take a little grayer. 10% gray. See how the lines came back? I don't want all those lines to be red for a very specific reason. So I'm going to select my outside shape again. Stroke color is a shift function. You notice it'll pile up some colors you use a lot right here in the corner. So now I have a black line and I got some red lines. And I have a shape. The black lines will be where the laser cuts. The red lines will be where the laser marks. I have this whole shape. It's still kaleidoscope, not colors. This is real subtle in Inkscape, and it's actually incredibly cool. This is a function that I have not experienced elsewhere that's valuable beyond description. It's actually more powerful than right-clicking in a Microsoft product and finding the little paintbrush, because you can paste great specificity. So I'm copying the whole shape, but I'm only going to paste part of it. Up here in the Edit menu, paste, paste in place, paste style, paste size. And when you do paste size, you can paste size, width, height, separately, etc. You can paste only bits of the metadata for each of these shapes. I'm only going to paste the style. But I'm going to undo that. Copy. Grab the whole shebang over here. Edit. Paste style. We got it. That's it. Now, I have a black and red shape, and I have a black shape. The black shape is cut lines. Those are going to be separate pieces. Black and red shape is going to be cut on the black and marked on the red. I want this side to remain of a piece for the moment. There is a shortcut for grouping. It's Control-G. So I could just do Control-G. Now I have a piece, just to prove it. I have this one. Control-G. I have a piece. Highlight everything. Control-A. Alignment. Middle. The distance is arbitrary. I'm going to group the whole thing. Control-A, Control-G, group the whole thing. And again, I got what I need. Up here, you can control the position. I can move this. See that? With incredible precision. You can also control the size. If I lock it, it will shrink and raise symmetrically. See that? I'm gonna keep it big. If I leave it unlocked, it'll go this way or it'll go this way, which I'm not going to do right now because I don't want to screw it up. So I have a nice convenient size. And I also know how big. 202.692 by 102.169. I can control the whole shape completely. Size, height, everything. This is as big. This is nice. So it's let's see, it's about 202 wide. About yay big, which means that each trefoil is about yay big. By 100, which is 10. Good enough. Nice. Tidy size. That stays right where it is. All the way back to the beginning. I'm going to take a square. We haven't used any squares on this one. Square is the same as the shape of stars, circles, whatever. I'm going to take a square. Take a square. And I'm going to make a square. And I don't need anything except to make the thing. Because I'm going to make it where I want it. Go back to the fill. You know how to do this. I take away the fill. Back to the stroke. Shift. The last color I used was black, so I want to make sure this is red. I don't care about the width of the line on this one because it's just this is another construction line. So, and I also don't care about anything being symmetrical. So I'm just going to drag it out. Now I have my border. When I make something to cut, I do this every time because it constrains the size on the laser bed. And then so I have my shapes, I have my place, I make my border, I put pips in the corners, then I take away the border. So this is going to be, I'm looking here, the width of the shape, 249 by 123. Want a little bit of border. You know, this is the fiddle about part a little bit. Yeah, we'll call it 240. Yeah, we'll call it 230 by 120. And I got that figure there. I assume this thing will do, you know, 3-place precision. I haven't pressed it. That's a convenient size. You notice that number is not quite precise? It's because of the line thickness or the corners assigned to that line. We've got a border, we've got our shapes. We're going to put our little corner pips in to control where the laser finds the limits. I have the Bezier tool. Making it bigger to exaggerate. It can be whatever length. It can be whatever thickness. This is going to be the corners to constrain the laser. Second one, third one, fourth one. There's 4 there. Trust me. Select border. And here's a good exercise for the alignment. Alignment. Align left. Align top. Select the border. Rinse, repeat. Right. Top. left, bottom. I'm not unshift selecting here because it's hard to get the lines. It's just easier to just start over. Yep. And you can see that in the picture. You can see the heavier lines. So I select this, delete it. That's my drawing. That's what's going to go to the laser. That's what's going to go to the next steps. Select them all. First thing I'm going to do is ungroup the snot out of it. That's really important. And just keep ungrouping until ungroup is no longer displayed. If ungroup is no longer displayed, I'm down to the simplest unit. Each vector is unitary. Group it. Now I have a drawing. I want to save this thing at a very specific size and note its size and its place so that I can use it later. And remember, it's a vector. It can be as big as it wants or as small as it wants. I can make this thing as big as a house. First thing I'm going to do is an interesting property of Inkscape. The document properties controls the size of the page, the orientation of the page, everything about the page. You can even change the color. What I'm going to do, resize to content. By resizing the content, I literally have a page, a drawing, the entirety of the drawing is sized to the exact same size of the content, the picture. With that, when I save, I can take that vector and put it at the 0, 0 coordinates of the laser. Mine's always in the lower left, others may do it elsewhere. If I do that, I can control my material and do a bunch of other just stuff to make life easier. So now, there we go. I have this. It's good to go. All I got to do is save it. File, save as. I'm just controlling the location. Desktop. I've already saved this once before. I already have a file name. I've said what it is. I've set its width, its height, so that I can pick up a piece of stock out of my stash and go right to the laser with it. And I've constrained it to the fact that it is an SVG file, a vector file. And I save it. Now, I've got a vector file. What am I going to do with it? Hold that thought. Welcome to Laser Gerbil. Laser Gerbil is step 2 of 4, I guess. Laser Gerbil is free. Laser Gerbil will run almost every laser there is. Laser Gerbil, once attached to the laser, knows what device you have. If you have multiple devices, you can control that as well. Laser Gerbil does some things well and other things not as well. What it does well is allow me to align it. It is perfectly capable of cutting. It cuts very inefficiently. There is no function in it that I've ever found that tells it to cut in a sensible order. And that becomes really annoying when you're cutting very thin material and you got the air blowing on it to blow the junk away, because they'll pick up and fly if you don't cut them in the right order. So for me, Laser Gerbil, I might engrave with it occasionally. Nowadays, I use it only for alignment as a fallback if I have a problem with light burn. Standard straight up stuff here. File, open. We're on the desktop. There's the tray foil. I don't have to think about anything here. That's the speed that the laser cuts. Faster is not always better. That's the mode for the laser. In this case, it would be constant. And you can set the maximum and the minimum. If I was going to cut this piece here, I'd maybe set it to 50%, run 2 passes at 300 millimeters per second. Look familiar? Well, there it is. It's also on 0, 0, the origin. And I can see that our grouping and ungrouping has left us with a drawing that will let us cut exactly what we intended to cut. So, pretend I'm out here and I'm in the laser and it's 150 degrees in the shade and all the fans are on and the doors up and the Camaro's in the driveway and we're just going to town. And at this point I hit the go button on the laser and I align material with laser girdle. Fine, it's aligned. Done. This is light burn. Light burn is not free. It's $40 per license. You get to keep the license for about a year, a major rev, I think, and then you stop getting updates. You don't necessarily have to continue to update. I do feel like I have better control. I've opened the file. You can tell that you can do a great deal more with light burn than you can with laser girdle. You can make your own parts in this if you choose to. And if you have multiple drawings, you can arrange it up so if you have a big piece of material, you can cut everything you want all at once. I usually don't bother. I tend to just cut a job at a time. I can control the movement of the laser head as precisely as I can in laser girdle. I can control the cuts. We'll get into that a little bit more in just a second. So the black one's going to cut, the red one's going to etch, so that I have lines, construction lines, so I can put stuff back, put it together. So normally what I do is select the whole thing, 0 tab, 0 tab. I've parked it at the origin, lower left corner. Physically on the laser, it's the same place. You notice something else about this thing. Red lines, black lines. The red lines, as I said, are going to be lesser cut. The black lines are going to be the piece, the cut that takes the piece out of the material. What you want to do when you set all this up is your black lines, you're going to have a higher intensity, maybe a little bit slower speed, because you're going to cut once. And then the part just falls off the material. This one, much lower intensity, maybe a little bit higher speed, because all you want to do is draw a black line. The other thing you can do is it cuts masks like you would not believe. I could have all kind of complex text on here and everything else, and I could choose to cut out the parts that I wanted to paint different colors. I'm not doing that here. This is all going to be base colors. So there's a zoom to the thing here. There we go. All right, we're good to go. This is ready to cut. I've already proven the 0, 0. I've got material on the bed of the laser. I'm going to hit the go button. I want to etch it before I cut it. So I put the etch cut first. Select one. Put the etch cut first. I double click on it. And I have control over it. It's not a CO2 laser, it doesn't matter. I'm going to probably leave that at 600, but I'm going to take this down to 20%. I just want to draw a line. I don't want to cut. So I've got that. I'm going to the other cut. 300 at 92.5 will cut this stuff. This stuff is defined as the mat board, and it cuts really nice at 92.5%, 300 foot per second, millimeters per second. The specific measure is 300 millimeters per second. Lasers go in millimeters per second. I think CNC machines do the same thing. This is now ready to cut. Can't now, it's not connected to the laser. I hit the start button, and here's what it will do. This is one of the best functions of light burn. First, it automatically selects a reasonable order for the cuts. Laser girdles all over the place. This guy cuts in a reasonable, sensible order. Second, it'll show you how it cuts. You see that last part, that goes, and you know when it's done because it gets back to the lower left corner again. And it's just simply mark its limits. So the time on there, 6 minutes. The way I have that stuff arranged, I should have enough of a line to mark where I can glue the parts on top of each other. And when I walk out to the garage after it's done, I'll just pick it up in pieces. Simple as that. Make as complex a shape as you want. You have to think in your head. You have to deconstruct anything that you're scratch building to layers, to flats. It's not 3D printing. It's all flat. But you've seen where I can make something pretty out of flats. There we go. That's all there is to it.
There it is. That's the tray foil. Cut out of 1, 2, 3, 4, 5, 6 pieces. And put on regular mat board. I spray painted it with good old fashioned primer paint from our favorite orange big box. I did a twin. This one is aged. It's flat, nothing special. So we followed our 3 steps. Built it in Inkscape to the accuracy that we desired. Created the SVG. We aligned the material with laser Gerbil and we cut it in light burn. I could do a million. Good stuff. There's one trick I learned during the production of this video that I want to include. That's mat board. This is the same stuff you use to place vinyl. And you put this over it, you peel the vinyl back, and you stick it in place. Thundermesa, I'm sure, uses acres of this stuff. I've covered both sides of the material. Mat board, regular mat board, it peels off with almost no damage, nearly none, pretty much doesn't damage it. And it keeps the smoke on this, not the material. This same technique allows you to cut clear material. Those who cut Lexan plastic use this because it focuses on the opaque surface and then performs its cut underneath. So every piece of stock now gets done with that, and all of this craziness, it's flippy floppy, that's not lazy. That's there so that I can stick it to the bed of the laser. You may have wondered what that was under there. It's some spare tile that came from the house. I got a huge pile of it, and I just, when it gets ugly, I throw it away. Well, the tile protects the wooden base of the laser and allows for a surface to cut on. This then simply sticks to it. I line it, stick it, shoot it, walk away, pick up the parts, and go home. The only hard part is then you got to pick it off the parts. That can get tedious, but it also reveals perfect parts. So much for that. What can I do with a laser? Simple. Maybe not so much. This is, I don't know how many parts I remember now. Red paint, yellow paint, markers. You see amethyst is purple, so we have to have a bit of a purple highlight. She's also a scout, a single nacelle Franz Joseph. It's actually a Saladin class scout, not a destroyer. But I imagined that on a heavy jacket on an away mission. His eyes glow. He's got the stars you stick on the ceiling are his eyeballs. I don't know that I've ever done him in a dark room, but I know it works. And just the beauty and simplicity of the Iron Man face. Okay, so now that's all two-dimensional. From there, we're now beginning to get some dimensionality. I splashed paint into my bathroom on the wall with a special color that I'm not sure I can replicate. And so I have to color, I have to hide the stain that's lying there. So this is going to become a greebler. But you see that it's plates of a relatively heavy basswood sheet. The holes will have screws in them to make it look like it's on a wall. This is going to have a handle around it to make it look like these cylinders pop away. There'll be some other fun stuff in here. And it's just going to literally cover two ugly spots in the paint on the wall. And I'll probably just screw it in. There's a step beyond that. You guys are all familiar with the ATST. There's a lot of other stuff that I've done since. This is the first stab. It's a rocket. It's called Copernicus 1. It was designed by a gentleman by the name of Dave Meek. Dave Meek is Thundermesa Studios. He's an illustrator of some incredible skill. And he drew one of these, touched my heart the minute I saw it, and these are the beginning of the results. Hole number 13, squadron number 555, because there's 555 dots cut with a laser and stuck in every transition. The plates here were not laser cut. The detail you see was laser cut. You see the other one in a second. The fins were laser cut. Barely any filing, because the accuracy is so high and so repeatable that I could make these exactly to scale according to Dave's drawing, in exactly the right thickness with two sheets. It's that perfect. There is a version of this that you can laser cut the hull out of poster board. There's a couple of different versions at the local grocery store. One of them is relatively wiggly, and I can cut this whole hull out of poster board and get, you know, jiggy with the CA and have this result. This one was a prototype, so I did the hull in paper. All these strips in the joints were my solution to the frustration of trying to get those in the right place and have a conical section. At the end of the day, laser cut. There's the Mark I. This is perhaps slightly closer to his vision. 4 fins. The hatches, you know, port and starboard are an extension thereof, because I didn't want to try to make these flat and go around the curve. So, all things you can do with a laser. Inkscape, free. Laser Gerbil, free. Light burn, significantly more superior, a significantly more superior product, and cheap. Fire it up, light it up. The paper doesn't catch fire, nothing burns. You just, you know, like I said earlier, don't look into the light. Make sure it's ventilated. This is not something you do on your table at the house. It's just amazing, really cool stuff. Someday, if the fates align, we'll have a video on this guy. Dave's given me his permission. Of course, I need to finish the ATST. I swear to God I will. The space station hasn't been touched during this adventure, but it proceeds, and you'll see the little mulligan video, God willing, pretty quickly after this. Glue and Paper Guy, signing off.